Hi everyone. So today in this video we are going to discuss about the LLVM compiler. So in the previous video we had discussed about the GCC compiler. How do we compile our code? How do we run our code? So with the help of GCC we had discussed in the previous video. But now we will do all those things with the help of LLVM. Okay. So let's start the video. So we already know about the compiler. Okay. So what is compiler? Compiler is nothing but it's a software program that converts our source code into the machine code, right? And definitely you guys know about it, right? So now let's move to the main topic. What is LLVM? So LLVM is nothing but low level virtual machine. Okay. So it is an open source project designed to help developers build and optimized programs. Okay. So LLVM serves as a toolkit that includes the compiler libraries, okay, and also various kinds of tools for various programming languages. Now the question is, what are the programming languages it support? So basically it supports C, C++, but also it supports other languages like Rust, Swift, Python, Java, and many more. Okay, let's discuss the LLVM compilation process. Okay, so if you see carefully, there are three major steps, that is front end and that magic engine and back end. Okay, so this magic engine is also called at mid end. Okay, so suppose if you return any program in any specific programming language, that is our input program, right? Now this input program will pass through the first part, that is front end. Now what it will do, it will give the intermediate representation file. People also called it IR file. Okay, so the front end part will give the IR file. Now this IR file will pass to the second step, that is mid end or magic engine. So this IR file will pass through the magic engine, and now it will give optimized IR file. Okay, so now this optimized IR file will pass through the last step, that is backend. Okay, so what it will do, it will provide optimized target machine code that can be executed, right? So now let's discuss step by step explanation of the LLVM compilation. Okay, so suppose you have written any program, that is our source code, right? The process begins with the source code written by any program, written by the programmer, okay, in any programming language like C, C++, Java, anything, right? Then it will pass through the first step, that is front end, right? And what it will do, it will perform the lexical analysis, syntax analysis, semantic analysis, and then that it will generate AST, abstract syntax tree. That is nothing but it's a hierarchical representation of our program. Now the question is, what is lexical analysis, which is also referred as tokenization? See, basically it involves the breaking down the source code, breaking down our program into the smaller unit, which is called as tokens. See, for example, definitely we will have used some keywords in our program, right? That is if loop, if block, or for loop, anything, right? Definitely we'll have used variable name, any constant numerical values, or any kind of operator in our program. So these are nothing but these are tokens. So now we can conclude that tokens are the fundamental building block of our program. Fine. So now the question is, what is syntax analysis? As the name itself suggests, it will check the syntax, right? So the primary purpose of this, it will check whether our source code, our program, follows the grammatical rules, that is our syntax rule of any programming language or not. either it is following or not. Okay, so it will check. How it will check? It will read the source code character by character. Okay, and then it will group these characters into the meaningful construct that is called as token that we have discussed right now. Okay, then after that it will build a hierarchical structure that is called as AST. So with the help of these tokens, it will build a hierarchical representation of our program, that is AST. Okay, so now let's discuss what is semantic analysis. See, syntax analysis is checking the syntax, but semantic analysis, it won't check the syntax. It will check the meaning and correctness of the code. So now you can get the idea. Now you can conclude that semantic analysis is more challenging than syntax analysis, right? So now let's discuss what is AST. So I already told you AST is the thing, but it's abstract syntax tree is a hierarchical data structure. Okay, see, AST is a tree like representation like this. So definitely there will be nodes, right? Nodes and ages like this. So these are children nodes, right? So AST is a tree-like data structure representation in which nodes and ages definitely there will be, right? So nodes correspond to the elements of our source code. Okay, and now these ages will represent how these elements are connected with each other, right? For example, suppose you have written any program, so definitely there will be some function, right? So function, our node might represent a function, okay, and its children nodes represents its parameter and body. Okay, so till now we got the AST. Now this AST is transformed into the LLVM IR file, intermediate representation. Okay, now the question is, what is IR? What is LLVM IR? See, LLVM IR is a low level platform independent programming language that serves as an intermediate language in the LLVM compiler. See, it's basically a low level programming language that act as a mediator. Okay, that act as an intermediate. Okay, see, LLVM IR consists of SSA. What is SSA? Static single assignment form. So what it will do? It will be making it conducive optimization. Okay. Now the question is, what is SSA? SSA is nothing but it's a static single assignment. Okay, see, SSA is a specific form of representing variables and their assignments in LLVM IR. What does it mean? See, in SSA form, any variable is assigned only and a value only once. That's why we are calling it static. Now let's discuss with the help of example. See here, x is equal to 5. Okay, so we have x is equal to 5. Then y is equal to x plus 3. Okay, y is equal to x plus 3. The value of x is 5. So y becomes 8. Okay. Now in the third statement, it is changing the value of x by adding 1. So now our x becomes 5 plus 1, that is 6. See carefully, here x is 5, but here x is 6. But our in SSA form, a variable is assigned a value only once, but here we are trying to assign the value of x 2 times. So this is not a SSA form. So basically what is it? It is non-SSA form. To make it in SSA form, we can we can store the value of x in new variable. So here we are using x2, x1, x2. Okay, so you got it right. So till now we got the LLVM IR, right? So this LLVM IR will be taken out by the LLVM optimizer, and it will perform some optimization techniques. What are these? Some optimization techniques are like vectorization, dead code eliminations, inlining functions, loop unrolling. So these are commonly optimization techniques. We are not going to discuss in details. Okay. Suppose you if you want, then comment it down. We will make some another video. Right. So till now we got the optimized LLVM IR. Now this optimized LLVM IR will pass through the backend part. What it will do? It will generate, see, the code generator, it will generate the target specific assembly code, or you can call it machine code. Now this machine code will pass through the target dependent optimizer. What it will do? It will further optimize this generated assembly or machine. So this is our final machine code. Okay, that can be executable. Hope you are getting my point, right? With the help of this diagram, definitely you will understand very easily what is happening exactly in LLVM compilation process. See, suppose you have written any program in any specific programming language, that is our source program. Okay, source code. Now this source code will pass through the front end. It will generate the LLVM IR. Now this LLVM IR will pass through the optimizer, which is also called as magic engine or midend, right? Now this, it will optimized IR file. Okay, so it will provide optimized IR file. Okay, now this optimized IR file will pass through the backend. Now what it will do? It will generate target specific machine code that can be executed, right? So now the question is, how can we compile and run our program? For the compilation process, for compiling the program, just write clang, then your file with the proper extension. Okay, and for running the program, just write /a.out. Okay, and you can also use some optimization flags, that is -o1, o2, o3 or o fast. Okay, so you can try it your own, right? So we will meet in the next video with the different topics. Okay, bye bye.